Today I'll be showing you how to convert between binary and hexadecimal. And just a quick heads up, I'm not going to go into too much detail on how to convert between binary and decimal, because I'm sort of just going to assume you already know how to do that. So if you don't, I'll link a video in the description on how to convert between binary and decimal. So let's start with converting a binary number to a hexadecimal number. First, you need to remember that hexadecimal essentially has 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then it has A, which represents 10 in decimal, B, which represents 11 in decimal, C, which is 12, D, which is 13, E, which is 14, and F, which is 15. And now to convert binary into hexadecimal, you split the binary number up into groups of 4 starting from the right. So we can split it up into groups of 4 like this. And we end up with 4 groups of 4. And then for each group of 4, you simply convert it into the equivalent hexadecimal digit. So starting from the right, 0101 in decimal is going to be 1 plus 4, which equals 5. So that means in hexadecimal it's just 5 as well. Next we have 1110, which is essentially 8 plus 4 plus 2 in decimal, which is 14. So in hexadecimal, that's going to be E. Next we have 0011, which in decimal is just going to be 2 plus 1, which is 3. So that means it's 3 in hexadecimal as well. And then finally we have 1011, which in decimal is 8 plus 2 plus 1, so 11. And in hexadecimal, that's B. So 1011, 0011, 1110, 0101 in binary is B3, E5 in hexadecimal. Alright, now let's try this one. So remember, the first thing we have to do is break it up into groups of 4 starting from the right. So we have one group of 4 there, another there, another here. And then even though we only have 2 digits left, we can still pretend that this 10 is a group of 4. Because we can just pretend that there's 2 zeros in front of it. And now that we have that, we can just do, starting from the right, 1101 in binary is 13 in decimal, so in hexadecimal, that's going to be D. Next we have 0111, which is 7 in both decimal and hexadecimal. Then we have 1100, which is 12 in decimal, and that's C in hexadecimal. And then finally we have 0010, which is just 2. So that means that this binary number in hexadecimal is going to be 2C7D. And now let's have a look at the reverse, converting hexadecimal to binary. And this is pretty simple because as long as you have the decimal values for each hexadecimal digit memorized, you should easily be able to convert it to binary. So if we just go one digit at a time, starting with A in decimal is 10, which is 8 plus 2, so that means that in binary, A is 1010. So there's our first group of 4. Next we can do E. E in hexadecimal is equal to 14 in decimal, and 14 in decimal is just going to be 1110 in binary, because 14 is 8 plus 4 plus 2. Next we have 2 in hexadecimal, which is just 2 in decimal, and that's 0010. And then finally we have 7, which is also 7 in decimal. So it's going to be 0111, because 7 is 4 plus 2 plus 1. So that's pretty easy. AE27 is just going to be this. Alright, let's do this one last example. So what's 6FD in binary? Well, 6 in hexadecimal is also 6 in decimal. So that's just going to be 0110 in binary, because it's 4 plus 2. And if you want, you can also get rid of that first 0, and it'll be exactly the same. Next, F in hexadecimal is 15 in decimal. So that means it's 1111 in binary. Because 1111 is 8 plus 4 plus 2 plus 1. And finally, D in hexadecimal is 13 in decimal. So in binary, that's going to be 1, 1, 0, 1. So 6FD in hexadecimal is 110, 1111, 1101 in binary. And that's how you convert between hexadecimal and binary. So thanks for watching.